Good morning, sir.
Good morning, sir. Good morning, sir.
Yes, good morning. We'll start the session. So, in yesterday's class, just to brief out what we have done, we have seen first type of conversion, that is uh, any number system to any to decimal, correct? Any number system to decimal. In this, we have seen three types of conversions, which are those. First one is binary to decimal. Second one is octal to decimal, and the third one is hexadecimal to decimal. So these three conversions we have seen, right? So the procedure is using the formula, right? The procedure remains same. Now the second type of procedure conversion is vice versa of this. If I say vice versa of this, that means decimal to any number system. Okay, decimal to any number system. Okay, so in this we'll be seeing again three types of techniques, that is vice versa of all these three. That is, the first one is vice versa of this is decimal to binary. The second one is decimal to octal, and the third conversion will be decimal to hexadecimal. Okay, these three conversions we are going to study today. Yesterday we have done with this. Okay, now the procedure for this three is same, and the procedure for these three conversions will be same. Okay, but not both are not having same procedure. This and this do not have same procedure. Okay, this is separate procedure and this is separate procedure, but for all these three conversions, that is decimal to any will be same, and any to decimal will be same. Okay, so we'll start decimal to binary first. Okay, first we'll start decimal to binary. One if you follow the first procedure, probably rest of the two procedure conversions will be easy, because the procedure remains same. Okay, so the procedure remains same, so just concentrate. First we'll start with the first conversion, that is decimal decimal to binary. Okay, so here let us say, let us take one example, then you will understand the procedure later. First we'll solve one example, and procedure will be understood easily later. First, if I tell procedure, probably it will be difficult for you to analyze what is what. So first we'll solve the problem itself, then understand the procedure. Okay, so let us take one example. Decimal, let us take one decimal number, 299.99. This is the decimal number. Some random numbers I'm picking. Okay, so it is in decimal, sorry, it is in decimal. Decimal means 2 should not come here. Okay, so it is decimal, and I should convert it to binary, so it should be 2. That is decimal to binary. Okay, decimal to binary conversion we are doing now. Please follow me what I am doing. This number has two parts, right? One is integer and fraction, correct? Any number has two parts, integer and fraction. Okay, now I'll take the integer part. Okay, I'll take the integer part. Here, what is the integer part? It is 299, correct? So I'll do successive division. Remember, for integer part, it is successive division. Okay, I'll do successive division. So what is that successive division? So I have to, what is the given decimal number integer part is divided by the required base number. The required base number. What is the required base number? It is 2, right? I have to divide the integer number by 2. This is the integer number. What is the required base number? It is 2. Okay, this is the required base number. So that is 2. That's why I am dividing that by 2. So what will be the quotient and remainder here? What will be the quotient? 299 divided by 2. What will be the answer? It is 149, correct? 149. It is quotient. And what will be the remainder? 1. Correct? Yes. So you have to write quotient just below the for the next iteration, and you have to write the remainder side. That means you are storing the remainder side. Okay. So repeat these steps until further division does not happen. Repeat these steps until further division does not happen. So again divide by 2. So what will be the answer? 140 divided by 2 is 74, correct? 74, and the remainder is 1. Okay. Next, again it is possible, division is possible. Again 2, 74 divided by 2, so it will be 37 times, correct? 37 times, and the remainder is 0, correct? Again divide by 2. Okay, 37 divided by 2, it is 18 times it goes, and the remainder is 1. Again divide by 2, 9 times, remainder is 0. Again 4 times, remainder is 1. Again 2 times, remainder is 0. Okay. So again 2, 1, you will get 1 here, and this is 0, correct? Have you understood the procedure what I did? Any doubts?
Yes,
Please?
sir.
Understood?
Yes, sir.
Right. So once you have done with this, okay, so you have to note down the reminders from down to top. You have to note down the reminders from down to top. So here we'll get the reminders from down to top. If I note down, it will be something like this. That is 1, 0, 0, 1, 0, 1, 0, 1, 1. Correct? If I note down the reminders from down to top, it will be in this way. Correct? Right. Now this is for integer. Integer part is done. Now we'll see the fraction part. Okay. We'll see the for fraction part, it is successive multiplication. Okay. So what is the fraction they have given? It is 0.99, correct? It is 0.99 is the fraction. So I have taken the 0.99 as fraction into 2. Here divide by 2, here into 2. What is the product of this?
1.88.
1.98.
1.98.
98.
1 point. Yeah, correct. Here you have to note down the integer. Okay, you have to note down the integer of the product. What is the integer of the product? It is 1. And the fraction part is moved to next iteration. The fraction part is moved to next iteration, that is 0.98 into 2. What will be the answer? 0.98 into 2, it is 1.96. Again, note down the integer part. Pardon? 1.96. Again, the fraction part is moved to next iteration. So 0.96 into 2. What will be the answer? 1.92. So it goes on. So here, what we have to do is, we have to note down all these integers from top to down. Here we have note down from down to top. Here we are noting down from top to down for fraction. So if I note it down, it will be something like 1, 1, 1, correct? So now the final answer, I can combine this integer and fraction and write the final answer something like this. That is 100101011 is the integer part, and fraction will be 111. So it is equivalent binary number. So
Sir,
the same
Sir,
procedure
why,
will be,
sir, why we have
yes,
stopped in 1.92 only? Sir, we have stopped after 1.92. Why?
see we can move on. So how long we can move on? You can do up to 4, 5, 10,
Oh,
100 also, but
sir,
we
it is
can
up to
stop.
our convenience that we have done only
Yes,
3 times.
yes. See, for example, here how many digits are there in fraction? 2 digits, correct?
Yes,
In the
sir.
given number. Huh? So
Yes, sir.
you better stop at plus 1 digit. That's quite enough.
Okay, sir.
Huh? Okay. If they
Yes, sir.
particularly mention up to 4 iterations or 5 iterations, you do 5 iterations. If they have not mentioned anything, you stop somewhere around 3 or 4. That's quite enough. Huh?
Yes, sir.
Right. Okay. So please understand the procedure. The procedure will be same. What is the procedure? The procedure is the given number will be having two parts, integer part and fraction part. So for integer part, we are doing successive division. With what division we are doing? By the required base number. What is the required base number in this case? It is 2. In case of decimal to octal, the required base number will be 8. So you have to divide by 8. In case of decimal to hexadecimal, the required base number will be 16. So you have to divide by 16. Okay. But the procedure remains same. Okay. So this is what the procedure is. Okay, this is for integer, and for fraction this is the procedure. We'll do one more problem, you'll understand now. Okay, take down one number, some number. So I'll take down some number as 325.12 in decimal equivalent. What should be in binary? Yes, can you do? Take down the integer part first, that is 325. Start dividing it by required base number is 2. So start dividing by required base number is, that is 2. So proceed. I'll keep doing. If I go wrong, please correct me. Am I going correct? Am I right? Is my answer right?
So
Yes, sir, it is correct.
Sir, in
Right.
the bottom it will come 0, no, sir?
Where,
last
ma?
second will be 0, sir.
Last
Yes,
is
this
0.
is 0. Correct. Very good. This is 0. Very good. Good. Next fraction part.
Sir,
0.12 into the required base number is 2. Yes. Yes.
you that is still wrong,
Sir,
sir.
with 5 it should be 1.
Where, ma?
Sir, third step from downside. With
That
5 it should be
0 will be
1.
not there, and that 0 will be above at the place of 1 where we divided with 2.
Yes, sir, the remainder should be 1 at 5.
Here. See, I'll tell you. 325 divided by 2 is 162 times, and the remainder is 1. Correct?
Sir, correct, sir.
162 divided by 2, the quotient is 81, and the remainder is 0.
Yes, sir.
So 81 again divided by 2, it is 40, and the remainder is 1. Correct?
Yes, sir.
Yes, sir. correct.
Again 40 goes 20 times, and the remainder is 0.
Yes, sir.
Again 20 goes 10 times, and the remainder is 0.
Yes, sir.
And 10 goes 5 times, and the remainder is 0.
Yes, sir.
And 5 goes 2 times, and the remainder is 1.
Oh,
Correct?
oh, I
2 into 2, 4. 5 minus 4, it is 1.
so remainder will be 1. No, sir. You wrote 0.
No, 1. See here. This case only, right? You're telling.
Yes, sir.
It is 1.
But we are dividing with 2. It will be 1 0. No, sir. There will be no remainder.
5
Nick,
divided by
Naveen,
2.
2 is 4. 5 minus 4.
So 1 will be at the place we wrote 0 after
Here.
5.
Here.
No, it is correct only.
Yes, sir, it's correct, I think.
No,
They
it
got
is correct.
confused.
He is getting confused. Let me correct him. Okay.
It is
No. Let me make him understand. See. Follow me.
Yes, sir.
325 divided by 2. How much quotient comes? 162.
Yes, sir. And remainder is 1.
Remainder is 1. Do you think that this is correct?
Yes, sir.
1 second. Right. Right. See. So this is correct for you.
Yes, sir.
And 162 divided by 2, the quotient is 81 and the remainder is 0. Is it correct to you?
Yes, sir.
Right. Then this 81 divided by 2 is 40, the quotient, and the remainder is 1. Is it correct?
Yes, sir.
Right. Then 40 divided by 2, it is 20 quotient and the remainder is 0. Is it correct?
Yes, sir.
Right. Then 20 divided by 2 is 10 is the quotient and remainder will be 0.
Yes, sir.
Right. Then 10 divided by 2, the quotient will be 5 and the remainder will be 0.
Yes, sir. Okay,
Right.
sir. Understood.
Right.
Yes, sir.
So
Understood.
5 divided by 2 is 2 is the quotient and the remainder is 1.
Yes, sir.
Right. And 2 divided by 2 is quotient is 1 and remainder is 0.
Yes, sir.
Understood?
Yes, sir. Understood, sir.
Right. So now we'll move on to fraction. Okay. Now in fraction, it is successive multiplication. So 0.12 into 2, what will be the product?
0.24.
0.24. So note down the integer part, and the fraction part is gone to next iteration. 0.24 into 2. .48. Again the integer is moon. 0.48 into 2. 0.96. 0.96 into 2. 1.92. So we'll stop here. So you note it down from top to down, and this we are noting down from down to top. The final answer will be what? That is, can you tell what will be the final answer? Combined integer part and fraction part. It will be 1
1
0
0 1
1 0 1 double 0 triple 0 1 0 integer, and fraction part will be 000 1. Correct? So base 2. This will be my equivalent binary number for the given decimal number. You can cross verify. How to cross verify? I have given you one thumb rule. Very simple. See, this position, this weightage is 1, correct? And this weightage is 2. It is not there. This weightage, third position weightage is 4, correct? And 8, 16, 32, 64 is there, correct? And 128 is not there, and 256 is there, correct? 256 plus 64 plus 4 plus 1, how much it comes? Just to cross verify this procedure is whether your answer is correct or wrong.
325, sir.
Is it correct? Correct, right? So this will be correct. Okay, this is just to cross verify whether the answer is right or wrong. Okay, right. So this is how we are going to convert any given decimal number to a binary number. Okay, now we'll move on to the second one, that is,
Excuse me, sir.
yes,
Sir, Rahul Bhatt is waiting in the lobby. Due to bad internet connection, he got disconnected.
admitted. Right. So we'll move on to second type of conversion in this procedure. Okay, so where do I find one page? Yes, I got here. What is second type in this procedure? It is B. It is B. So it is decimal to octal. I'll take one random decimal number, say 498.96. Some octal number I have taken, a decimal number I have taken. I need to convert it to octal. So 8, that is 10 to 8. That means decimal to octal conversion it is. Okay. Now start performing with the same procedure. So what is integer part here? 498. In the given number, 498 is the integer part. So divide by which number I have to divide now? Required base number. What is the required base number?
8, sir. 8.
8. So divide by 8. Start doing. How many? What is the quotient and what will be the remainder? 498 divided by 8. It is 62 is the quotient, correct? 62.
Yes,
And what
sir.
will be the remainder? 62. 2.
2.
So it is 2, correct. The remainder will be 2. Next, divide by 8. 62 divided by 8. It is 7 times, correct?
Yes, sir. Yes, sir.
Yes, sir.
What will be the remainder?
6.
6, sir.
Right. So further division does not possible, correct? So further division is not possible. Stop there. Okay, stop there. And this completes integer part. Note down from down to top, and we'll see that later. Okay. Now fraction part. So 0.96, it is successive multiplication. 0.96 into 8. What will be the product?
7.68.
7.68. Right. So note down the integer, and the fraction is moved to next iteration. Okay. 0.68 into 8. 5.44. So take down the integer part, and the fraction is 0.44 is moved to next iteration. .52, correct?
Yes, sir.
Right. You stop here. Okay. So note down this from top to down. So final answer, we can combine this integer part and fraction part. We will get 7, 6, 2 dot 7, 5, 3. Correct. So this is in octal. Understood?
Yes, sir.
Right. We'll move on. We'll take one more example in this. Right. Can you do? So integer is 195, and the required base number is 8. Divide by 8. How much you'll get? 24.
Yes,
Yes,
sir.
sir.
So the what is the remainder?
3,
3, sir.
sir.
3. 8, 24 is divisible by 8. Again do division. 8 3s are 24. Correct? 3 times, right? Is this
Yes,
right?
Yes,
sir.
sir.
Up there. Further division doesn't happen. So noted. We have noted down from down to top. Again, take the fraction part in this. That is 0.13 into 8. What is the answer? Product 1.04. Take down the integer, and the fraction is moved to next iteration. 3 2. 0.56. You stop there. Okay, so this we have to note it from top to down. The final answer will be correct in octal. Is it correct?
Yes, sir.
Right. So now what we'll do, we'll see the third type of conversion in this procedure, that is decimal to hexadecimal. Okay, decimal to hexadecimal. In exam, sometimes they'll ask something like this. Okay, say for example, can you see here? Please look at the board. They'll ask something like this. So can you tell? We have to convert the given decimal number to octal, and also we should convert the given decimal number to hexadecimal. Or sometimes what we have to do, first convert to octal, again from octal to hexadecimal you can convert. These two conversions we have not seen, how to convert from octal to hexadecimal. But we know the procedure how to convert from decimal to hexadecimal, correct? So they'll ask like this only in exams. Okay, so we should be ready for this type of solutions. Anyhow, we'll solve this type of problems further. We'll see there. Okay, now we'll see conversion, that is third conversion, that is decimal to hexadecimal. Decimal to hexadecimal. Where do I get some page to do? Yes, I got here. Right. Third type of conversion in this procedure is decimal to hexadecimal. Okay, take down some number. Example 1, 952.93 in decimal. You need to convert it to hexadecimal, means 16. So 10 to 16, base 10 to base 16. That means decimal to hexadecimal you have to convert. So what is the procedure? 952 is the integer part in the given number. Required base number is 16. So divide by 16. So we have to do successive division for integer part. So what will be the answer? What will be the quotient and remainder? With the quotient and remainder. Is it 59?
Yes, sir. 59.
So what will be remainder?
8.
8. Divided by 16. It is 3. And remainder will be
11.
pardon?
11, sir.
11.
11. So 11. Right. So I told you, write 11 itself, but the equivalent numbers for A is what? 10.
10.
B
10.
is 11. C is 12. D is 13. E is 14. And F will be 15. Correct? So this 11 is nothing but, what is the value of 11 here? It is B. Write B. and leave it. Okay. Have you understood what I did?
Yes, sir.
Right. Now, because in exam or test, you will get confused and you will write something answer like this. It is wrong. Value completely changes. This is wrong. So you should write in this way. This is where you will go wrong. Okay, this is wrong. You should not write this. Okay, because the value of this completely changes. So be careful at these points. Okay, so you see now fraction part. So 0.93 into 16. What will be the answer?
14.88.
So what is the value of 14? E. Correct?
E.
So the fraction is taken for next iteration. How much you'll get?
14.08.
Again it is E. 0.8 into 16.
1.28.
Check it out.
Yes, sir, it is 1.28.
It's 0.08, sir.
14 point.
It's 0.08 into 16.
Yes, it is 0.08. Correct. So it is 1.28. So 1. Stop here. Okay. So note it down from top to down. So this is from down to top. So the final answer will be how much? Is this correct? Is this correct?
Yes, sir.
Yes, sir.
No,
sir, B, sir.
No,
That's
sir,
why.
we need to in the place of 11.
Yes. Generally you go wrong here. Okay. So don't do that mistake. It will be 3B8.EE1. Okay. This is the right answer. Okay. Right. We'll see one more example. We'll take some 523.153 in decimal to question mark in hexadecimal. Yes. Do it. The integer part is 523 divided by how much? 16. What will be the quotient and remainder? Make it fast.
Quotient 32
Yes.
and
What will
remainder 11.
quotient is
32.
32 and remainder is 11.
11.
11. So its equivalent will be B, correct? (16 divided by 32), 2, correct? And 0. So this is done. Next fraction, it is 0.153 into 16. What will be the answer? Product?
2.448.
2.44.
And
2.448.
448. So I can write here 2, and this fraction I'll take out to for next iteration. That is 0.448 into 16. Yes.
7.168, sir.
7.168. So 7 here and 0.168 for next iteration.
Two 2.68.
Pardon?
2.68.
2.68. So 2. This is enough. Okay. Note it down from top to down, and this is from bottom to top. The final answer will be 20B dot 272. Correct? So this is your hexadecimal number for the given decimal number 523.153. Okay. So this is how we do conversions. I think we have completed 6 conversions. Which are those? So where do I find some space to? Yes. So far we have seen 6 types of conversions. The first one is, I think in the first page I have written somewhere. Yes. Let me go there itself. Yes. So we have seen binary to decimal, octal to decimal, hexadecimal to decimal, right? And then the second type of procedure, we have seen again 3 types of conversions. That is decimal to binary, decimal to octal, decimal to hexadecimal. That means we have covered so far 6 types of conversions. And leftover type of conversions are, say, I mean to say this is one, binary to octal, and vice versa of this, that is octal to binary. And next we need to do binary to hexa, and vice versa of this, that is hexadecimal to binary, and octal to hexa, and vice versa of this is hexadecimal to octal. So this procedure is a bit different from this. Okay, it is quite easier and you'll enjoy doing this. This we'll do in next class. Okay. Totally there will be 12 types of conversions. If you can calculate, this is 6 and this is 6. Okay, that is, this is 3, here you have 3, and here you have 6. So total there are 12 types of conversions. Okay. If you are familiar with this, then number systems is done. Okay, you can get minimum 6 marks from this in your main exam. Okay, and it is very important for your career also. Okay, so before going to next class for this type of conversions, okay, what we have to, you should have some basic knowledge This is a general knowledge. Okay. 1 second. You should have some general knowledge. I'll just teach that and I'll wind up the class today. Okay. Say for example, for octal number system, listen carefully. For octal number system, how many characters are there in octal number system?
0 to 7.
That means there are totally 8 characters that are from 0 to 7, correct? So 0 to 7 means the maximum character in octal number system is 7, correct? So I can represent that 7 in binary as 311, correct? In binary, I can represent that 7 as 311. Okay. So I can write something like this 0, 0 to 311 if I want to represent it in binary. Okay. So if you see hexadecimal, the total characters are 16. Which are those? 0 to 9 and A to F. So what is the F value, maximum digit? F maximum digit is F. What is its equivalent binary number? It is 4 ones, correct? So I can represent in binary something like this, means 4 zeros to 4 ones. What I mean to say is, for octal representation, okay, for octal representation, if we are dealing with octal numbers, then maximum number of digits will be 3. Maximum number of digits will be 3. 1, 2, 3. If I am dealing with hexadecimal number system, it will be 4. Can you see here? It is 1, 2, 3, 4. Here we have only 3. This is the only basic difference between hexadecimal and octal. So make a note. For octal representation, grouping of 3 is done. For hexadecimal representation, grouping of 4 will be done. Okay. So with this basic idea, tomorrow we'll move on to this type of all these 6 conversions. We can complete that in one period in the next class. Okay. It is quite easier if you know this concept. Okay. Octal number system is grouping of 3. Hexadecimal means grouping of 4. Okay. So with this, we'll wind up the class, today's class. If you have any doubts, you can stay back or else you can leave the session. Okay. Take care.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Take care.